on the given number line. We know for that we have to draw one number line. In the center of number line, we always place 0. After distance 1 centimeter, suppose it is 1, 2, 3, 4. These natural numbers are placed. Also -1, -2, -3, so that on this number line we have now shown all the integers. Now we know fraction also we can show on this number line by dividing this in given segments. Suppose I have to show 1 by 2, then I have to divide this in 2, and here is 1 by 2. If I have to show 1.2 also, then I have to make 5 segments here. 1, 2, 3, 4, and this is 5. So every one represent 0.2. So it is 1.2. It is 1.3. 1.4. It is 1.6. 1.8, and this is 2. In this way we can show integers, fractions, number in decimal, all on this number line. Then how can we show irrational numbers on the same number line? So let us start from simple ones, that is under root 2, under root 3, under root 5, because we know under root 4 is 2. So let us start from these simple ones. So for that, on the similar number line, we can show all these numbers. How? So we have to take help of Pythagoras theorem, and if we want to construct root 2 or show root 2 on this number line, we have to construct a triangle. 1 unit here we have taken. We have to calculate the distance. We have to calculate this 1 unit distance, and the same distance we have to take on perpendicular. We have to draw perpendicular. Make sure it is perpendicular by using protractor D. Take 90-degree angle. Now this 1 unit distance is measured here, and I found this point here. So now I will join this hypotenuse. So it is a right angle triangle, and by Pythagoras theorem, if we name this A, B, C, then use the Pythagoras theorem. By Pythagoras theorem, AC square, that is hypotenuse square, is equal to AB square plus BC square. So as we have taken AB 1 unit, so it is 1 square plus 1 square, that is 1 plus 1 2. So AC square equal to 2. Taking square root, the distance AC is root 2, and hence the distance AC is root 2, and we will take this distance AC and mark R on number line, and hence we can place, because this distance is root 2, so we can place root 2 here. position of root 2 on number line. Similarly, if we want to find out root 3 position, then again construct perpendicular here, perpendicular line. Now we know if you take point D here, so this distance AD is root 2. Just we have taken. So again I have to take 1 centimeter distance, 1 unit distance here. For example, it is E, and I have to join this A and E. I will join this A and E here. So again by Pythagoras theorem, in this triangle AE square equal to AD square plus ED square But just now I have drawn AD equal to root 2. This I have taken root 2. So AE square equal to placing root 2 for AD distance plus ED, I have taken 1 unit. So AE square equal to root 2 square, that is 2, 1 square is 1. So AE square equal to 2 plus 1, 3. Taking square root, AE will be equal to under root 3. And hence, again, taking this distance, and by drawing, we can draw, if we draw this R, this distance is root 3. And in this way, we can place root 3 on number line. We have placed root 2, root 3. Again, if we want to place root 5, then you can take 1 centimeter on 2. So this distance is 2. Square of 2 is 4. If we take 1 unit here, then 4 plus 1 5, and take R, you will get root 5. In this way, you can draw any number on this number line. Also, same way can be done on negative side, and we can find out minus root 2, minus root 3, minus root 5 by arranging similar thing on this side. Now, challenging question comes when we have to present root 2.3 suppose, or any number in point. So it is the challenge. Let us see how to solve this. Now let us start representing such number. Now it is somewhat challenging because we cannot take direct two numbers which are the square roots of which are equal to the addition of square root. So we have to construct a different method for it. Let us first construct root under root 2.3 here, and then we will see what the logic works behind this construction. So for that, I have to first take 2.3 distance 2.3 so it is the distance Then I have to add 1 unit, that is 1 centimeter, in this given figure. I have to add 1 unit in this given figure. So here I extend this like segment. So I take here suppose C. So this is distance 2.3 and I have taken 1 unit again extended. Now I have to take perpendicular bisector of this given segment. Let us first learn how to construct and then we will see logic behind it. So I have drawn a perpendicular bisector here for this segment. That means I am getting midpoint of this segment. So it is the midpoint of this segment. And now I have to construct a circle taking this point as center. This is the circle now, which is taking. So this was the midpoint and this is the circle. Now wherever the B comes, we have to take perpendicular here. And if perpendicular is drawn from B, let us take this point D. Now this distance BD is equal to the root 2.3. So I have to take this point B and D, this distance, and place this distance here, and it is the place for the point. This is the place for the point root 2.3. So you understood the procedure. First you have to take the distance whatever you want to take, add 1 unit again, take the perpendicular bisector so that you can find the midpoint, draw a half circle, and then wherever the point B comes, take a perpendicular which where it cuts the given circle is the distance you want to draw. Now let us see the logic behind this. That when we draw a distance, suppose we want to draw under root x. So we take distance x here. Okay. Then what we will take? We take 1 unit again. That means if this distance is A, this distance is B, this distance is C. The whole distance AC is x plus 1. Okay, understood? Then we take the midpoint by drawing perpendicular bisector. We take midpoint. That means let us take this midpoint here. By drawing perpendicular bisector, we find the midpoint. Let us take this midpoint as O. And then we draw a circle taking this radius, half circle. Now understand the concept behind it first. We have taken AB distance as x. So distance AC comes out to be x plus 1. Now this is the midpoint. That means distance AO is midpoint of x plus 1. So distance AO is x plus 1 upon 2. But it is the radius of this given half circle. Now what about this distance OB? This distance OB. What about this distance OB? So the full AB distance is x, and we have to subtract this AO distance to find out the OB. So OB is equal to x minus x plus 1 upon 2. Okay, by taking common denominator, we have to multiply this by 2. So twice x minus 1 upon this 2. So twice x minus x is x minus 1 upon 2. So distance OB is x minus 1 upon 2. Now we have to construct the right angle here. So let us take this right angle and we will join this D and O here. So this is the radius of half circle, same circle. Radius is AO. Now it is the right angle triangle again, and we can use the Pythagoras theorem. So by Pythagoras theorem, OD square is equal to OB square plus BD square. OD square, we know it is the radius, and we know the radius of this half circle, which is x plus 1 upon 2 square, equal to OB square. Just now we have found x minus 1 upon 2 square plus the distance BD square, which we don't know. Now taking square of this, it will be x square plus twice x plus 1 upon 4. Taking square of this, x square minus twice x plus 1 upon 4 plus BD square. Now let us take all these terms on this side, we shift them here. So we will find x square plus twice x plus 1 upon 4 minus, that means all the signs of this polynomial will change, and they are going to subtract from here. And again the denominator is 4. That means the same denominator is there, no issue. So minus x square minus twice x plus 1 upon 4 equal to, we are going to find out BD square. BD square will remain here. So let us write on this side. So this will become x square plus twice x plus 1 minus x square plus twice x minus 1 upon 4. So x square minus x square will be cancelled, plus 1 minus 1 will be cancelled, and bd square will be equal to twice x plus twice x, that is 4x upon 4, that is bd square equal to x, and taking square root, the distance bd comes out to be root x. In this way, this distance bd is equal to root x, and that we have to take into account and draw it on the number line. So, I think you have understood the logic how we have to construct such half circle, and then we have to place the irrational number like root 2.3, root 9.2, anything you can now show on number line, and you can find place for every irrational number on this